Screen check. Mic check. Mic check. Mic check. Audio check. Good. Okay, we're good. Eesh. Alrighty. Let's get this show rolling. We've got 30 seconds on the line for day 5 of Advent of Code. As always, we're going to be solving this bad boy in Clojure, so get ready to go. We got our REPL up, got our input ready to receive, and 15 seconds on the clock, more or less. Alrighty. 6, 5, 4. Here we go. Okay. There's a suit. It's material formed by polymers, formed by smaller units, which, when triggered, react with each other such that two adjacent units of the same type and opposite polarity are destroyed. Units types are represented by letters, and polarity is represented by capitalization. Okay. A, and A react, leaving nothing behind. A, B, B, A. B, B destroys itself, leaving A, and then it destroys itself again. This is a fixed point problem, isn't it? Okay. Got it. So we just have to keep reacting. Oh my goodness. Oh no. This is going to be really long. Okay, so let's grab all this and just toss it in here. And we're at that. Okay, this is going to be crazy. Let's make sure I actually run my buffer now so I get my input ready. Deafen, collide. Whoa, okay, let's work on syntax here. Let's start with this, because I have a suspicion we're going to need it in that form. Okay, this is where I need to actually already need to look up something about characters. Character. Upper? Ugh, okay. Java character. And equal to character slash 2 uppercase X character 2 uppercase Y. So if the two characters are the same, so S and S, for example, and is lower case x and character is uppercase y, or whoops, there's our and then outside the and we want, so either x is lowercase, y is uppercase, uppercase x and is lowercase y. Let's just validate that this works as intended. So let's see, collide A, B should not. A, B. False, okay. That should. Lowercase and lowercase should not work. Okay. And lastly, uppercase, lowercase, true. Okay, I think that gives us enough simple test cases. We could go full with it, but I'm fairly used to with that logic. We're fine. Okay. Let's see. There's a couple ways we could do this. I think we will literally just start by... We could always just keep taking the first one we see and then starting over again. Really, whenever you make a match, what you're doing is you're actually stepping back and checking to see if it affected the one before you. So the propagation can basically start crawling backwards if you keep on stacking characters that end up... So for example, if we had something like this, E, D, C, B, A, you notice we would eliminate these, then move back to here, eliminate that, back to here, eliminate that, etc., all the way back to here. Another way to think of it is that you stay where you are and you allow things behind you to collide with you, but that doesn't make any sense either. Your index is still going to be decreasing. That doesn't make sense. This is actually possibly one of the problems. It's not going to be easy to do in Clojure. Maybe this is something you could do with like a tree structure? Maybe? I think I see what I'm gonna do here. This is a stack problem. Oh, it is a stack problem. Okay. What you're doing is you're putting a character on the stack, putting another one on top. If they blow up, you pop off the stack, and then your next state is just whatever's still there. Right, so it's a stack, it's a stack, it's a stack. Okay, this is okay. Okay, so let's try it this way. I like it when you can finally figure out the model for a problem. Okay, so, given... Okay, I'm going to eliminate the, let's see. I think it's R? No. Kill rectangle. I don't remember what the command. Control XRK? Okay, I'll have to keep that in mind. Oh, I definitely do not like that. What are we going to call this guy? Let's see. push, care, what do they call these things? They call them elements? Units. Push unit. Okay. We have a stack, and we have a new unit. Notice this is a reducing form as usual. Okay. If these two collide, empty stack yeah, that we make a list basically with that unit inside. Otherwise, we're going to go ahead. I think that's what that does. Hold on. Okay, that's not what I want. I just want a list of unit. I think it'll work. Okay, I keep forgetting you can't use the literal syntax in Clojure lists. I don't use them that often, but they work best for a stack type situation here. So, otherwise, I should probably be using cond here. If the stack is empty, we're going to make a list of units. If the first item on the stack, the top of the stack, is going to collide with the unit, then we're going to just return the bottom part of the stack. I always have to check this one. Which one is it? Is it rest? That gives you back a list? Possibly empty seek. Okay. So next is the one that gives you nil if you go to the end of a list. I don't think it would be a problem, but otherwise we're going to conj conj does not take an else clause. I wish that cond and case would have the same structure, honestly. It is a little frustrating that they're inconsistent. Minor gripes, but it is something I have to keep looking up because I don't use it often enough. Onto the stack, we're going to add our unit. So that's going to push the new character on the top of the stack. It didn't collide or anything. We'll leave it be. And I think that's it. So let's add some tests here. Let's push unit. List A, B, C. And we're going to add a D. I didn't actually define my thing. So, D, A, B, C, that's what I expect. So D's at the top of the stack now. Let's check what it does with an empty list. Okay, works. And what happens when I give it a matching? Pow, gives me back an empty list. We're good. Okay, now we're going to reduce our input. Reduce with push unit, starting with an empty list. Input. Okay, That looks reasonable. I'm going to go ahead and get a count of that, and that should be our answer. I'll have to validate it. Oops. 11253. They want us to find how many units remain after fully reacting the polymer. Not right. It doesn't give me a hint about how big or how small. So it should progress linearly, though. Okay, let's go to the very beginning here. I'm gonna try something. So reductions, push unit, input, and I'm going to take 20 reductions. So I'm going to see what the first 20 steps look like. So we get V, V limits itself, B, big B eliminates F, P, big P eliminates the P, and then we have a big F which eliminates the F. R, Y, big R, Y, R, big R, Y, big R, little r, capital I, so it eliminates, big N, little p, big Y, little y, etc. There's a new line at the end. Oh, come on. Isn't there a strip? Not template. Strip, trim? Trim. There we go. 11252. Dang it. Okay, that's part one. That wasn't too bad. This is where it's going to be hard. Time to improve the polymer. One of the unit types is causing problems, preventing the polymer from collapsing as much as it should. I have to figure out which unit type is causing those problems, remove all instances of it, regardless of polarity, fully react the remaining polymer and measure its length. So it's one of the one of the letters specifically I'll have to remove entirely. Okay, so I think we have every letter represented here. Let me validate this. Set input. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Yep, okay, so one for every letter is represented. Def and split. My own special sauce here. Type. Let T-type be character that's 2 lowercase t in a function of units equals T-type unit. So that'll test whether 2 characters are of the same type. Okay. That's. Did I guess it did. Okay. I guess we can kill all these now. DD. Let's make another function real quick. Just that encapsulates this entire thing. What do they call it? Collapse. We're going to collapse our polymer. Okay, yeah, when you collapse a polymer, you do it by reducing with push unit, starting with an empty list, that polymer. This is our part 1 solution. And we're just going to say, we're going to count how many things are present when you, come on, collapse the input. That is nice and succinct. I like that a lot. Range from A to Z. Does not like. Int A to int Z. Okay, map. Care. That should work, I think. There we go. Okay. Sometimes you gotta do silly things to get things working. Okay. we're going to define that as all units. Did not like that because I have an extra power in here. That's all units. Map all units with something that no, we need something to filter them out. So let's see, filter polymer of type unit, unit type, I guess. Is literally just filter polymer let the type filter be unit type of type. So that gives us a predicate now. In there's got to be a negate, I thought. Not. Predicate? No? Pred? No, okay. Well, fine. Let's do it the weird way. You know what? Let's just make this called not unit type. Make this not equals. Now we're just removing a whole category of things we have to worry about. Type filter. Not unit type filter polymer. Done. Okay. Let's make sure we actually run this. Run this. Let's try filtering our polymer input of A's. Do you see any A's? I don't see any A's. Are there any A's up front? There's some early. Okay, I think we got it. Hash FN removed unit as removed unit to collapse filter polymer and we want to know which one gives the smallest So we should probably generalize the count a little later. And I hit insert again. Hey, do I do that? Okay. Let's see. Refactor thread. Oh, wow. Okay, well that doesn't work as well as I'd hoped. Maybe if I go out here. Definitely doesn't work. There we go. Interesting. We're gonna sort this. This might take a little bit. It's gotta do the whole collapse function 26 times, but the collapse function was running fairly fast before, so hopefully we'll get our results quickly. I really probably should be p-mapping this. There we go. We got it. A with 10,756. Oh no, I didn't order them right. Where did Z go? Because I excluded Z. Int Z. I'm an idiot. Okay. Okay. Let's make sure we redefine that. This time, sort by second. There we go. That should give us the smallest count first. And I'm gonna actually just take this entire section. And I'm going to make sure that we can reuse it by... There we go. So once it runs, it'll replace it right here. It'll take a bit, but, you know, I'm willing to wait. It wasn't too long. That was maybe a minute. Slower than I'd like, but I'm not going to be fussy about it. Although I do wonder what PMAP would give me here. Is that in this? Yeah, PMAP. Yeah, I could definitely probably replace that with a PMAP. Oh well. Okay. There we go. In with definitely a very small count. 6118. Wow. Okay. Let's enter that in. 6118 is the smallest. Submit. Got it. Okay, that wasn't too bad. But that was much easier. Okay, how's the leaderboard look for today? Personal stats. Still pretty terrible, pretty slow. But this is a much shorter one than yesterday, by all counts, with that kind of rank. So I'm in line, I guess, with my previous ones. Cool. Clojurians, looking good. Okay. Awesome. This is a pretty tidy one, actually. I'm pretty happy with it. I am curious now to see what kind of performance I get, though, out of PMAP. So I'm just going to try that real quick, just so we can see what kind of results I get. Format buffer. Right. And I'm just going to run it this time. Not replace it. And this machine, for all I know, I'm just killing my stream right now doing this, because I have no idea. Oh, it's definitely slow. Did it finish? I think it might have finished and I just didn't notice it. No, it's still going. Boom. Oh, okay, that's actually fairly faster. It's not like lightning fast, but it is definitely significant. So I'm going to go ahead and thread that as well. All units. PMAP. Sort by second. First, second. And that'll give us our actual count. So label this as our part 2 solution. So we never actually just collapse it. We always collapse it and count it. So collapsed size of the polymer is the count after reduction. So literally the first solution is just to, so I hit insert again, I did. Collapse size of our input. And that makes this down here factor function No, that's not gonna work. Okay. I don't know if this will work, so I'll save it first. I think I can make this anonymous still. I think it'll accept that, which is my big concern. I don't know if it accepts that up front, or if it'll just see it as I'm trying to call the function, which is a vector. Actually, you know what? I can just use vector. Okay, yeah. Vector, percent, thread, percent. You know, I don't even need thread at that point. This is so small. Collapse size. Okay. Oh, duh. That's even easier. That should take 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, that's pretty fast. That's 30 seconds or so. I wonder if the filter should be lazy, so I don't think it'll save us anything to sit there and just reject it during our traversal. So during our collapse, basically. I don't think we're saving ourselves anything, because we should only be consuming that list as we go, and that'll handle the rejection at the time of evaluation. Yeah, I think I'm satisfied with what we have. There's not that much to this one, honestly. Yeah, I think I'm happy with this as it is. It's not that complex a problem. Everything we've got seems tidy enough. We've got enough caching here to make me comfortable that we're not having to recalculate this a whole bunch. Yeah, this is a fun one. And it gave us a nice vocabulary to work with too, which is always fun. Actually, let's refactor this real quick. Rename symbol. The refactoring tools I'm seeing for Cider are kind of slow. It's a bit of a bummer. It might only happen once, but that's still inordinately slow. Okay, X is going to be unit A. Let's see if this is any faster. Refactor rename symbol. Oh no, it does have to reevaluate it every time. That is not gonna fly. Okay. I have to wait for it again. That is... I'm mildly disappointed. Well, this is a fun stream to watch. If anyone's watching this and they have used Cider before, they could let me know what on earth can be done to improve performance and stuff like that. Let me know, because I'm probably just missing something silly about Emacs. Alright, Unit A, Unit B, I like that terminology better. Push units onto a stack. The collapse size of a polymer. I like making sweeps to name things after a domain, especially after a problem like this. If there is a nice tight set of language terms that they use, it just makes everything read a lot more fun. And call that silly of me, but I like good names. I like them a lot. Okay, I think that's pretty much it. There wasn't really much to go off of today. Nice and sweet and easy. So I'm going to go ahead and commit this up as is, and we'll call it for the day, and I'll see you tomorrow, day 6 of Advent Code. As always, enjoy Advent Code, and keep learning languages, especially Clojure.